Welcome. Have you ever read a health headline one day telling you a specific treatment works, and then literally the very next week another headline tells you the exact opposite? Yeah, it is incredibly frustrating. In the field of clinical psychology, this kind of conflicting research used to be a massive roadblock. So today in this explainer, we're going to teach you exactly how scientists cut through all that noise to figure out what actually works. We're looking at a process that moves the field away from subjective opinions and into rigorous, hard data. We're diving deep into what researchers call the gold standard for synthesizing research, the meta-analysis.
Here's our roadmap for today. We'll be hitting the problem, the solution, the process, the math, the obstacles, and finally, the impact. Let's get right into it.
Section 1. The problem. Does therapy actually work? Let's travel back to the mid-20th century to really understand the historical conflict that birthed modern meta-analysis. It seems like a pretty simple question, right? Does therapy actually work? But back then, this was a massive, highly debated, and honestly a pretty troubling question for the entire field of psychology. Practitioners felt they were helping people, but the scientific data, it was completely all over the place. Some studies said yes, some said no. How do you objectively prove that talking to a professional heals the mind? To see just how intense that debate got, let's look at a quick timeline. In 1952, a prominent psychologist named Hans Isaac dropped a total bombshell. He claimed that therapy was essentially useless, arguing it was no more effective than spontaneous recovery. Basically, he was saying, people just get better over time on their own anyway. Well, as you can imagine, this sparked a massive controversy. It wasn't until the 1970s that a new methodology began gaining prominence to truly answer this. And that culminated in a landmark milestone in 1977, when researchers Smith and Glass synthesized an incredible 375 psychotherapy studies. They realized they needed a totally new tool to resolve this debate once and for all. Which brings us to Section 2, the solution, the meta-analysis solution. So think about the contrast between the old way of doing things and the new way. The traditional literature review is kind of like a really long college term paper. It's a descriptive narrative account where an author essentially just picks articles they think are important and draws conclusions based on their subjective impressions. As you might guess, this is highly prone to selection bias. You can cherry-pick data to support whatever you already believe. But the meta-analysis, that is a totally different beast. It takes a systematic review where you explicitly identify and appraise all relevant research and takes it one massive step further. It actually extracts the data and subjects it to rigorous quantitative statistical analysis. Let's define this really clearly. A meta-analysis is a quantitative research review utilizing statistical procedures to aggregate, combine, and compare the results of multiple independent studies on a single topic. But here's the absolutely crucial concept I want to teach you today. In this framework, the individual research studies themselves are the participants. You aren't testing a group of 50 people anymore. You're testing a group of 50 entire studies, pooling thousands of individual participants together to increase your statistical power far beyond what any single study could ever achieve on its own. It's brilliant. Moving on to Section 3, the process, step-by-step synthesis. So how do researchers actually build one of these things from scratch? Well, it's a highly disciplined 5-step recipe. Step 1, you formulate clear, unambiguous questions to guide your search. Step 2, you set criteria for inclusion. You have to establish minimal quality standards, so maybe you only include studies that used highly reliable measurement tools, or maybe a specific minimum sample size. Step 3, search the literature extensively across electronic databases, places like PsycInfo or PubMed. Step 4 is to extract the outcome data and code the relevant study characteristics. And finally, Step 5, assess quality. You have to critically appraise the included studies for any risk of bias. It is an incredibly meticulous process. Section 4, the math. The math behind the magic. Now let's look at the invisible math making this all work. Think about the practical problem of combining 375 studies. One study might measure depression on a 10-point scale, while another uses a completely different 100-point scale. How on earth do you combine them? You use what's called an effect size. This acts as a universal translator, converting all these diverse results into one standardized metric. While there are a few different types of effect sizes depending on the research, one of the most common for comparing groups is Cohen's d, and that represents the standardized mean difference between a treated group and an untreated group. Let's make that math really tangible for a second. What does an effect size actually look like in the real world? If a meta-analysis finds a Cohen's d of 1.0, that is huge. It means the average treated participant scored one full standard deviation higher than the control group.
To put that into perspective, that places the average treated person at the 84th percentile of the untreated population. That kind of precise estimate tells us exactly how powerful an intervention really is.
But you can't just take all these effect sizes and average them out equally. Studies are weighted. A very common strategy here is the weighted least squares method. Basically, if a study has a massive sample size and very little room for error, it gets assigned far more weight in the final calculation. And why is that? Because a larger, more precise study is much more likely to be closer to the true population value than, say, a tiny study with just a dozen people in it.
Section 5. The obstacles, the file drawer problem, and other villains.
Every superhero needs a villain, right? And statistical analysis is no exception. The biggest villain here is publication bias, famously known as the file drawer problem. This is the super frustrating tendency for academic journals to only publish studies with exciting, statistically significant results. If a researcher conducts a study and finds that a new therapy does absolutely nothing, well, that's boring to publishers. So it gets shoved into a file drawer and totally ignored. To fight this, meta-analysts have to actively hunt for what's called gray literature. We're talking unpublished studies, conference presentations, and doctoral dissertations. They even use tools like funnel plots, which visually graph the data to reveal if smaller, negative studies are mysteriously missing from the literature. Researchers also have to dodge a few other major traps. First up, garbage in, garbage out. A meta-analysis is ultimately only as good as the quality of the studies it includes, period. Second is the apples and oranges problem, formerly called heterogeneity. If you try to combine studies that are just wildly different, say trying to mix data on GPA outcomes with data on severe depression outcomes, your overall pooled effect size is going to be completely meaningless. And third, dependency. Meta-analyses rely on the math of the primary researchers. If the original study made calculation errors, the meta-analysis will inherit those exact same errors. That's exactly why researchers must be incredibly scrupulous during that data extraction phase. Section 6. The impact. Real-world clinical impact. So we've learned the math in the process, but what does this actually mean for patients? Remember Hans Eysenck in 1952 claiming therapy was completely useless? Well, meta-analysis definitively proved him wrong. By combining massive amounts of data, researchers proved that the average person receiving therapy is better off than 80% of untreated people. The evidence is undeniable. This objective foundation is incredibly powerful, not just for practitioners, but for shaping large-scale healthcare policies that actually affect our lives. But the field has moved far beyond just asking, does therapy work? Meta-analysis now drives evidence-based practice, or EBP. We can now answer the much more important question, which specific treatment works for which disorder? Through focused meta-analyses, we've identified empirically supported treatments. For instance, data shows family involvement significantly reduces OCD symptoms. For anxiety and panic disorders, we know for a fact that cognitive behavioral therapy significantly outperforms relaxation therapy. And beautifully, recent data proves that for ethnic minority youth, culturally adapted treatments are often as powerful as, or sometimes even more powerful than standard treatments. This is the real power of setting clinical benchmarks with hard data. We've covered a lot of ground today in this explainer, transforming how we look at conflicting research into a really clear understanding of the gold standard of evidence. So I want to leave you with a provocative thought. The next time you see a flashy headline declaring a brand new miracle cure or completely debunking an old one, think about the file drawer problem. Think about effect sizes and weighted data. Will you settle for a single small study, or will you ask for the meta-analysis? Thanks for learning with me today.